Right, students, welcome to the final lesson of our number patterns unit and also the final part of the financial applications of our number patterns unit. And thank you for making it this far. For this lesson, we're going to be looking into balances that involve compound interest. And when it comes to this sort of compound interest, it's going to be with different terms in terms of different annual terms. So we'll come across new words when we get into the lesson. So our intention today is to be able to calculate balances for your compound interest that are non-annual compounding periods, meaning it's more than once a year. So it's not just once a year, but more than that. And our success criteria is going to be able to identify the principal amount. So remember how much you're beginning with. Identify the interest rate and the time that the money is borrowed or invested for, so the percentage rate. Determine the number of compounding periods, so it's going to be non-annual, meaning more than once a year. And calculate the interest that you earn, and use a recurrence relation to calculate your compound interest. Loans or investment. Remember the difference between a loan and an investment. If you're loaning, you have to pay the interest. If you're investing, you get the interest. So it gets given to you or you gain the interest. Alright, so let's get into compounding periods. We know that when interest is compounded annually, it means that it's compounded once a year. So that's what that means, yeah? Compounding annually means compounding once per year. Meaning that you're just being paid a new amount of interest every year, once a year. But interest can also be compounded or calculated or compounded in periods. Meaning that instead of just once a year, your money could be compounding twice a year, 3 times a year, 4 times a year. Okay? And this is where we get these words. Now, you've probably seen these before. Annually, 6 monthly, quarterly, bi-monthly, monthly, fortnightly, weekly, daily. Okay? So these words represent the number of compounds in a single year. Annually means once, so you get compounded once a year, or your money will be compounding once a year. 6 monthly, okay, means your interest or your principal gets compounded twice a year because it's every 6 months. Quarterly means every 3 months, so it's 4 times a year. Bi-monthly is every 2 months, so 6 times a year. Monthly means 12 times a year because there's 12 months in a year. Fortnightly means 26, okay, because there's 26 fortnights in a year. Remember, fortnightly means 2 weeks, every 2 weeks. Weekly, obviously 52 weeks in a year, and daily 365 days a year. So you'll need to refer to this when you come across multiple compounding periods per year. So I would recommend that you put this in your notes, or you just make a note of this so you can understand what to put for your number of compounds, the letter N. Okay? Alright, so interest rates and different compounding periods. Interest rates are based on an entire year. Therefore, if you have interest calculated more than once a year, the rate R, okay, this needs to change, okay, depending on the number of times it's being compounded per year. Here's an example. 5,000 is invested at 6% per annum, compounded monthly. So how do we figure out the percentage rate if it's being compounded monthly? Okay, so for our R value, remember the original R value that we were using, so the common ratio that we were using to calculate was this. This is the original, 1 plus the percentage over 100. Okay, or sometimes you'll see it as 1 plus R, which is the percentage rate over 100. But I'll leave it as percentage so that we'll know that that's the percentage rate. This is the original. That's if you're only compounding annually. Okay, but now that we have more than one compound per year, okay, that percentage rate isn't going to be just that 6%, okay, in this question. Instead, however, what your new formula is going to look like is this. Okay, and I'll rewrite that here. So it should look like this. R equals 1 plus, I'm only adding literally one thing, the percentage divided by N, which is, remember, these N's. Okay, and 1, it could be 2, 3, 4, 5, 6, whatever. It depends on whether you're working on annually, 6 monthly, quarterly, bi-monthly, monthly, fortnightly, weekly, or daily. So you got to look at these. Again, make a reference back to this table. So it's going to be 1 plus percentage divided by the n over 100. Okay. And perhaps if your calculator is a bit funky with this, I would recommend you put this in a bracket. Don't have to, but probably a good idea too, just in case your calculator isn't able to properly work it out. Because sometimes it won't. All right, and so if that's the case, using our formula here that we learned, and you can see, looking at this part, we've moved on to the next. It's going to be 1 plus the percentage rate, remember, was 6 right there. So that's why we put 6. Okay, and the n, okay, refers to, see how it's 12? It refers to this, how many times it compounds. So if it's compounding monthly, it's going to be 12. Let's go back to this. If it was compounding fortnightly, okay, that n here will be 26. If it was compounding weekly, okay, the n here will be 52. So you got to read the question to see how many times it's compounding per month. So that means the R value calculated in your calculator will be 1.005. So the common ratio is 1.005. That's what you're multiplying your current term to get the next term. Okay, 1.005. All right, here's another example. Let's try this. 3,000 is invested at 6% per annum for 2 years and is compounding quarterly. Okay. So there's a couple things we need to know already here. Your V0 or your initial value starting term is 3,000 and the percentage rate is 6%. Okay, and the number of compounds, or the number of years, sorry, is 2 years and it's compounding quarterly. Okay, quarterly, that's a keyword there. So if you look back at quarterly, how many compounds is that? The n value is going to be 4. So that means that quarterly means it's going to be 4. So I'm going to circle important things. 3,000, 6%, 2 years, compounding quarterly. Okay, so keep those important numbers in mind. So there's 4 questions here. State the principal amount and the number of compounding periods. Calculate the percentage change, the R value, or the common ratio, you could say. Write a recurrence relation for the investment. Then calculate the value of this investment. So part A. Oops. Part A. So state the number, the principal amount. So we know that the principal amount is 4,000. Easy. And the number of compounding periods. So in this case, it's 4. Okay, it's compounding 4 times per year. So the number of compounding periods in this case is 4. This is 4 times per year, all right? Part B, calculate the percentage change R. So remember the formula that we used? Okay, I'll write it here again because it looked like this, the way I wrote it. R equals 1 plus that percentage divided by n over 100. And you can put it in brackets if you want to. Okay, and that's what we have here. So R equals 1 plus the rate, which is 6%, so that's what we have here, divided by the number of compounds. So the n, 4, is referring to the number of compounds. We also put it here. And that equals 1.015. Part C, let's write this in a recurrence relation. Remember, in a recurrence relation, you got to have T0. So what's the starting term? Now, remember, this is just for when you're using these sort of financial questions, because generally you'll have a starting term, okay, where you start off with a certain amount. And Tn plus 1 equals Tn times the R. Okay, that's what a recurrence relation should look like. So in this case, T0 is 3,000 right here. I'll look at the question. And in our R value, so the value that we're multiplying by is 1.015, which is this. Okay, and there it is. All right, the next part is a little bit tricky. Calculate the value of the investment. So how much money will this person have after 2 years? Now, some of you might be mistaken and think, oh, I'm only multiplying this 2 times. But that's not the case. Okay, remember, this is 2 years, and each year you're compounding it 4 times. Okay, because it's compounding quarterly. So you're not going to just multiply it twice or get the next. You're not just looking for term number 2. Okay, think about how many terms that will be if it's for 2 years and you're doing 4 times per year. Because the investment is compounding quarterly, okay, over 2 years, the total is 8 periods. So you're actually looking for term number 8, not term number 2. You have to read the question properly, okay? In this case, it's 2 years and it's compounding 4 times per year. So you're looking for the 8th term. In other words, think of it as every year you're being paid interest, or you have to pay interest 4 times. Therefore, if you have to pay interest over the 2 years, how many times will you have to pay interest overall? So it's 2 years times 4, or 4 terms times the 2 years, which equals 8. So you're looking for term number 8. So start off by using your recurrence relation. So look back to what it was right here. I'll rewrite it for you guys. So remember, the recurrence relation was T0 equals 3,000. So you're starting off at 3,000. Remember, T0 means starting term, not the first term. Tn times 1.015. So there's my recurrence relation. So start off by putting T0, which is 3,000. Okay, and look at the recurrence relation and how to get the next term. You're multiplying by 1.015. So to get the next number, T1, multiply by 1.015. Okay, which equals 3045. Repeat that process. Multiply 3045 by 1.015, 3090.68. Multiply again by 1.015, and you get 3137.04. And you repeat the process, okay, until you get to, remember, we're looking for term number 8, T8. Okay, so that means T6, T7, and T8. Right there, 3379.48. So that means at the end of the 2 years, the total amount, investment amount, will be 3379.48. Now, to do this on your calculator, okay, so start off by writing down, here's your recurrence relation, the starting term, so 3,000. Then we press enter, okay, and then we multiply by, look at the recurrence relation, multiply by 1.015. I just pressed times 1.015 and it gave me ans, which was 3,000 times 1.015. So that'll be this first one here. So this is term 1, term 2, term 3, 4, 5, 6. Okay, and you can see term 6, 3280.32, and I've just rounded it because it says 329. Round that to 3, and then term 7 and term 8. Okay, so that's how much money we'll have after the 2 years, working it out on the calculator. And that's basically it. So go ahead and do chapter 3L, or exercise 3L, which is attached in this, in your in your team's assignments. Okay, so if you have any questions, let me know, please. Thank you.